going to be forced to step on your friend's shoes, your teammate's shoes, your colleague's shoes, how would you do so? How would you want them to step on your shoes if they had to? That is a question, non-obvious question, that we will explore in this next segment. I introduce you to a tenacious young Elixirist who has a name that you will not soon forget, Alvaro Cachero.
The idea of today is to see how we can crack the PubSub code. So we are going to deep dive into how we can work with PubSub, how we can use PubSub in Elixir, and then we are going to see some use cases to understand a little better the concept, okay? But first thing first, a little of introduction. I'm Alvaro, I'm from Uruguay. I've been working with software for 10 years, mostly contributing at the backend, being involved in companies of various sizes and across different domains. Right now, I work as a staff engineer at Whiteworks. Whiteworks is a company located in Uruguay that offers software services to clients, mostly in the US, working with Elixir, Ruby on Rails, among other tech stack. Also, in the past, I worked as a Java developer and as a Salesforce developer. Then in my last 3 or 4 years, I've been working in Elixir, and definitely I will be investing my upcoming years in this great technology. This is the agenda for today. We're going to start talking about what is PubSub, then how we can use PubSub in Elixir using Phoenix.PubSub, and then we are going to see some use cases, some example, one for backend lovers and one for front-end followers, okay? So, what is PubSub? It is a message design pattern. It is used in distributed system for asynchronous communication between different components or services. Although it is based on earlier message paradigm like event broker or message queuing, it is a more scalable and flexible solution. It was built for dynamic scaling, so PubSub was created to help the expansion of the information system. In the pre-internet era, the systems were designed with fixed or predefined resources that couldn't be easily adjusted based on demand. In other words, it was created to scale statically. But when the internet was starting and the mobile and IoT devices was rising, obviously systems needed to scale dynamically. So PubSub emerged as a key solution enabling elastic scaling, efficient load distribution, and real-time responsiveness. Also, PubSub it is capable of meeting scalability requirements because pooling is not needed since it is a push-based delivery, so consumers don't need to be checking for new messages periodically. Also, it's avoid overloading the design of our architecture with too many components, so the system can scale efficiently without adding unnecessary complexity. And also, we need to take into account that it replaced the point-to-point connection with a single connection with a message topic, which simplifies a lot the communication and the integration between the different components. This is the architecture of PubSub. So we can see that it is a framework that enables the message sending between publisher and subscriber. Publisher are those components that create and send the messages. Subscriber are the components that receive and consume that information. But the publisher will not be sending the messages directly to the subscriber like a point-to-point connection. Instead, they will be using an intermediary component called message broker. The message broker will be grouping the messages into entities called channels or topics. So whenever a new message arrives to a specific topic, it will be delivered to those components that are subscribed to that topic. And this is architecture, simple yet effective. Okay, let's see how we can use PubSub in Elixir. In order to do this, we are going to use the Phoenix.PubSub module. So this is a real-time publisher subscriber service. So we can use this to use PubSub. It is a distributed real-time messaging system which enables the process to send messages, to broadcast messages, and also to subscribe to topics. It allows scalable message broadcasting across nodes, which is crucial and vital in real-time systems, for example, in system alert, in live updates, or for example, when we are creating a chat. And also, it has support for different adapters or backend. So what is this? We can see Phoenix.PubSub like an abstraction that will allow the processes to communicate using the PubSub messaging pattern. Then we are going to have the underlying implementation or the concrete module known as backend or adapter, the one that will be providing the actual implementation for message distribution, defining how messages will be propagated across the processes. So let's see the available adapters that we have to use, we can use in Phoenix.PubSub. The first one is Phoenix.PubSub PC2. This is the default adapter. So in order to send the messages, we are going to be using distributed Elixir. Just to clarify, PC means process group, it's not Postgres. I know it's a little tempting to think that it's Postgres, but it has its origin from Erlang. So this is a screenshot taken from the documentation of Erlang about the PC2 module. So in short, the way that PC2 will be dealing with message sending is the following. We are going to have processes that belong to groups, so we can send messages to one, some, or all the members of a group. However, PC2 itself doesn't provide a built-in function or functionality to send, to broadcast the messages. So what we need to do is to manually execute some function to retrieve the list of nodes that belong to a list of processes, and then send the messages to those processes that belong to that group. Then Phoenix.PubSub will wrap PC2 and implement the necessary logic to broadcast the messages. This is the PC module. In fact, this is the last version. This is the underlying module that we'll be using in Phoenix.PubSub. So if I recall correctly, PC2 was deprecated from OTP 23 and was removed from OTP 24. So basically, the last version is PC. The main difference between PC and PC2 is that this last version has some enhancement, for example, when we work with large cluster, or some improvement regarding the logic around when the processes are joining and leaving the groups, among other differences. This is a screenshot of the commit that does the PC module into the Erlang repo. We can see, for example, that this was added in February 2020. Maybe the font is a little small, but this section is comparing the difference between PC and PC2. We already mentioned some of them, like the improvement regarding when the processes join and leave the groups and the large cluster. But if you're going to deep dive into all the difference, you can take a look about the commit that adds the PC module into the Erlang repo. Second, we are going to have the Phoenix.PubSub Redis. In order to send a message, we are going to be using Redis as the backend. So in order to set up this, we need to add the Redis PubSub dependency in our project and also have a Redis service up and running, which is the main drawback of this approach. So if the Redis server fails, then our backend is down and we cannot send messages. Okay, so we need to take that into account when we work with this backend. And finally, we have the Phoenix.PubSub adapter. So with this backend, we can create our own custom adapter for example, fit the specific needs of our project. And in order to do this adapter, we need to implement 4 functions: broadcast, direct broadcast, child spec, and node name. So giving an implementation to those 4 functions, then we can create our own custom adapters. Okay, but what are the steps I need to follow to set up PubSub? Well, the first one is to include Phoenix.PubSub as a child of the main application supervisor. In general, this is already added, but it is good to take that into account. Then we are going to subscribe to a topic. In order to do this, we are going to be executing the subscribe function of the Phoenix.PubSub, providing the PubSub name and the topic. Then we need to broadcast the message. We need to send the message. So again, we are going to provide the PubSub name, the topic, and the message that we want to send. And finally, the last step is to add the logic to handle the incoming message. In this case, we are using the handle info, receiving the message and the socket, because this is an example of LiveView. But for example, if you are working with a GenServer, instead of receiving the socket, you are going to be receiving the state of the GenServer. Okay? So let's see some use cases. Let's get our hands a little dirty. And first example, we are going to see how we can work with a GenServer, the one that will be sharing the state using Phoenix.PubSub across nodes that are connected using libCluster. And also, we are going to see how we can make real update between a LiveView page, the father, and a LiveView component, the child, broadcasting messages from child to parent using Phoenix.PubSub. Okay? So this is a regular Elixir project. In the application.ex, I have the topology for connect the node using libCluster. As we mentioned before, we have the Phoenix.PubSub child as part of the children of the main application supervisor. And then we have this GenServer. The name is car count store. Why this name? Imagine that in the two examples that we are going to see next, we have a very large collection of cars in our garage. And since we love Elixir, the idea is to create an application so we can track the amount of cars that we have in a garage, order, for example, by the brand of our car. Okay? That will be our reality. So this is the GenServer. We can see that in the client part, we are starting the state as a empty map. Then we have two public functions, one to get the brand counter. So providing the brand of the car, I want to retrieve the amount of cars that we have in our garage. Also, I want to increase the brand counter by 1. Then in terms of the callbacks, in the init function, we are going to be treating the handle continue callback to set up PubSub. So here, every time a new GenServer, a new node is created, I'm going to be subscribed to PubSub. Then in terms of the callbacks, I have the handle call to get the brand counter. And then we are going to have the handle cast, so providing the brand name of our car. We are going to be incrementing by 1 the amount of cars that we have with our brand, and then broadcast the message using, obviously, Phoenix.PubSub. Remember that if we have a broadcast, we need to add the logic to handle the incoming message. So in this case, we have this handle info. So every time a new message is sent using PubSub, then that state will be the current state of the GenServer. So let's give this a try. I'm going to start 2 nodes that will be connected using libCluster. So the first one will be the node 2, and this is the node 1. We can see in the logs that this is subscribed to the topic, GenServer's example, cars counter, and this is the node that is also connected with the same topic. Also, for example, if we take a look about the nodes that are connected, node 1 is connected to node 2, and node 2 is connected to node 1. So right now, we have full connection between the 2 nodes. Okay? So what I can do right now is copy and paste the module name, and for example, execute the function increment car counter. For example, let's say that I have 3 Hondas in my garage. So in the other node, since the state is synchronized, I can, for example, execute the get brand counter. And if I check about Honda, I can see that the other node has the same information. Okay? This is a simple way in which we can broadcast messages using PubSub. In this case, we are using the default adapter, but let's unplug the default adapter and plug the adapter that is using Redis. Okay? In order to do this, in order to use this, remember that we mentioned that we need to have a Redis server up and running. So I will run a Redis server in my local, and I also will start the monitor sentence so we can see the messages going through the backend. Okay? So let's repeat the procedure. We can see that the first node is connected, and this is subscribed. We can see the logs in the Redis CLI, and also I will create another node connected, and also will be using Redis as the backend. Okay? And then the procedure will be exactly the same. I can start broadcasting messages, for example, in this node. I will increment the broad counter. I will have 2 Ferraris, and in the other node, if I see the amount of cars that I have in my garage, I can see that I have 2 Ferraris. Okay? Remember, the main drawback of the Redis server, the single point of failure. So right now, I have a Redis server up and running, but what happens, for example, if I close the Redis server? Okay? In this moment, I am killing the backend that is Redis, and can see that I cannot be sending any more messages because basically the backend is down. Okay? That is for the backend example. Let's now switch to the front-end example. Continue building our great garage collection. In this case, we're gonna see a front-end example. So what we are gonna do is a UI interface, so we can create new cars, so we can organize the collection of cars in our garage. Okay? In this case, we have a LiveView page. In the mount function, I will ask if the socket is already connected, if the socket is already created. If that is the situation, I will be subscribing to PubSub using the function that we already saw. Then I will be fetching the cars that we have stored in my database, and then just I will be using stream to store the car and assign it to the socket. Okay? In terms of the render, I will have 2 main components. This will be the live component, and this is the child component that will be in charge of handling the form logic to create new cars. The second component will be just a function component, and the idea of this is to iterate through the stream of cars and show, for example, the brand of the car, the model. I can show, for example, I can delete the car, and I can say, let's say that, for example, we sold a car, we can toggle the status between available and unavailable, so that car is not more in our garage. Okay? In terms of the callbacks, I have the toggle status to turn on and off a car. I have the handle event to delete a car. We are going to see next that we have a trash bin, and every time we hit the icon, we are going to be deleting a car. And then the 3 callbacks related to PubSub. Okay? Every time the child module will be sending a message, the father will be receiving that message, and through PubSub, we are going to be updating the stream, so we can have live updates every time we make some modifications in our car garage. Okay? In terms of the child component, this is a live component. In the mount function, I will just create an empty chain set. Then in the render, we're going to have a regular form with 2 input fields, 1 to enter the brand of the car, 1 for the model, and then just a save button. Every time we hit the save button, we are going to be triggering this event, the handle event, and we're going to be creating this car using Ecto. A detail here is that every time we create a new car, we are making the broadcast as a function in our pipe. So we insert the car in our database, and then we make a pattern match with the result of the insertion. So if the car was created with successful, we are going to be broadcasting the messages. Otherwise, I will not be send any message because I don't want to show the result if the car is not created correctly in the database. That being said, let's give this application a try, and let's see how this is actually working. So what I will do here is just go to localhost/cars and open another tab, going to the same URL. In this case, I have 2 open tabs. I have 2 open sockets, and both of the sockets are connected using libCluster. Okay? Sorry for the UI. This is the best backend developer can do, but let's start adding new cars. For example, I can add a Ferrari. I can add, for example, a Honda S2000. But in the other tab, for example, I can add a Fiat Abarth. Imagine that we are short of money and we need to sell our loved Honda, so this is not available in our garage. The same can be happening to our Fiat. And imagine that in the middle of the night, someone stole our Ferrari, so we are not having our Ferrari anymore in our garage. So this way, we can have live update between different tabs, between different browsers, easily using PubSub. Okay? I wanna show you one more slide. So let's sum up and reflect about what we learned so far. Phoenix.PubSub enables scalable real-time apps by powering reactive fault-tolerant systems, whether using GenServer, LiveView, or cross-node messaging. Ideal for distributed asynchronous solution, efficiently handling fruit-taking publishers and subscribers, decoupling components for highly responsive applications. So, with nothing more to say, I just want to say thank you for being here and have a great rest of the day.
Well, we thank you too, Alvaro. I appreciate you coming and sharing your knowledge with the CodeBeam community and making your debut here. Is there any questions? PubSub is certainly not novel, but it is reliable, tried and true, and I'm glad that we have another tool in our tool belt. And so everyone, let's thank Alvaro and go on with our evening. This concludes day 1. Yeah.